Okay, we will start off this video with using the first definition of ratio. The most important thing for ratio, we will be using our calculator to reduce the fraction because a ratio is a reduced fraction. So the first example, which I'll give you a second to write, in Logan's High School there are 190 teachers to 2,650 students. We want to know what the student to teacher ratio is. So in this case, we need to have students on top, teachers in the denominator. So if we have 2,650 students, that'll be on our numerator. And we have teachers 190. So a ratio is a reduced fraction, so we'll go into our calculator, type in 2,650 divided by 190. We'll press enter, and that's going to give us a fraction, but we want the reduced ratio. So we're going to go and press math, and then the number 1, or you can just press enter, enter. Math, enter, enter gives you the reduced fraction. So it's 265 students for every 19 teachers. That's our reduced ratio. So then the teacher to student ratio, we would have teachers in the numerator and students in the denominator. So we would have 190 teachers to 2,650 students, which 190 divided by 2,650 is going to be the same ratio, just reduced in the reverse order. So it would just be 19 to 265. So the next question is actually a real life question. I use it all the time when I cook. It's how can we make predictions using ratios? And when you're making a prediction, when you already know, say that there's, you're making a batch of cookies and you want to make 36 cookies, but the recipe calls for 24 cookies. So you've got to be able to reduce the amount of ingredients, and you're going to do that using what's called a proportion. And a proportion is going to be two ratios that are set equal to each other. So we could say A to B equal to C to D. That's two ratios. This is a ratio, this is a ratio, and they're set equal to each other. Okay, so we'll go ahead and work this example together, and you're going to need to write it down. If it takes 3 cups of sugar to make 21 cookies, how many cups of sugar will it take to make 48 cookies? So you can set up your proportion any way you want. If you want to do sugar to cookies or cookies to sugar, either way is fine. I personally am just going to do sugar to cookies. So how many cups of sugar for how many cookies will be made? So to set up my proportion, it's going to be two ratios set equal to each other. I just have to remember that I'm going to use the cups of sugar on the numerator and the cookies on the denominator. So in the beginning, I have 3 cups of sugar makes 21 cookies. So 3 cups make 21 cookies. How many cups of sugar will it take to make 48 cookies? So I know the cookies go in the denominator, 48, and I'm looking for how many cups of sugar it will take to make the 48 cookies. So now that we have a proportion, we can cross multiply to find out how many cups of sugar it's going to take to make 48 cookies. So I would do 21 times x equals 48 times 3. So 21x equals 140. Dividing by 21. I will get a decimal, but I'm just going to round. You're going to get 6.85. So I'm going to round that to 6.9. So it's going to take about 6.9 cups of sugar for me to get 48 cookies. Okay, so I'd like for you to write down and try the next example on your own. It says, a survey was conducted that showed of 75 students polled, 12 of them were vegetarians. If we polled 300 students, how many would we expect to be vegetarians? So I want you to pause the video, set up your proportion, and solve the number of students. Okay, and you should have gotten 48 students. If you're not sure how I got that answer, go ahead and raise your hand and ask one of us and we'll be happy to help you. Okay, so if you recall in the textbook when I had you look up the definitions, similar polygons are going to have exactly the same shape, but they're not necessarily the same size. So for example, all hearts, the shape of a heart, they're the same shape, pretend that they are, but they don't have to be the same size. So they're called similar. We know that two polygons are similar if their corresponding sides have the same ratios and their corresponding angles are congruent. So it's a little bit different than last chapter. Last chapter we talked about congruent triangles and congruent polygons. So everything we just set equal to each other because everything was the same. With similar polygons, only their angle measures will be the same. Everything else will be called proportional. You're going to see this symbol. It's called the tilde, and it's how we denote that two polygons are similar. It's the same symbol that's on top of the congruent symbol. So right here, that symbol reads is similar to. So again, remember that similar polygons have proportional sides and their angles are congruent. So if triangle ABC is similar to triangle DEF, which angles are congruent? And you may be saying, well, where's the picture? Just like with congruency statements, this is called a similarity statement. Just like congruency statements, we don't need a picture. We go by the order of the letters. So the angles that are congruent would be A and D because they're in the same location, B and E because they're in the same location, and C and F. So angle A would be congruent to angle D, angle B would be congruent to angle E, and angle C would be congruent to angle F. The proportional sides, the same thing. We look at the similarity statement to see which sides are proportional. Again, it's a matching game. AB would be, the ratio of AB to DE would be congruent or equal to the ratio of BC to EF and equal to the ratio of AC to DF. So let's start with the first two letters. So side AB over side DE would equal side BC, last two letters, over EF, which would equal the first and the last letter, AC over side first last letter, DF. And we're going to use these proportions to solve for missing sides. So the question is, how do we determine if two triangles are similar? And that's what we're going to be working with in the next example. If two triangles are similar, their corresponding sides will have the same ratios. So we're going to set up ratios of corresponding sides, and if the ratios are equal, then we know the triangles are similar. Let's go ahead and look at an example, maybe make more sense. Okay, so the example is determine whether the two triangles are similar. If yes, what is their scale factor? And yes, I do want you to draw these pictures. That's why you want to have a ruler and take note how the angles are marked. So we're going to set up ratios of their corresponding sides. So we're going to have three ratios here. So I noticed that N and P, there's one arc and then there's nothing. That's this number 15. I'm going to match it up here with one arc and then nothing, so 12. Then I come here to NQ where there's one arc and two arcs. That's 12.5. And I come over to this triangle and look for the one arc and the two arcs, and it lies here with the 10. And then the last side is 11.5, which is in between two arcs and then nothing. So I come here where there's two arcs and nothing, and it matches with 9.2. Then I would determine if the ratios are equal. So is 15 divided by 12 equal to 12.5 divided by 10? And is that equal to 11.5 divided by 9.2? And notice how all three ratios equal 1.25? Since all three ratios are equal, we would say yes, the triangles are similar. and their scale factor is this 1.25, but as a reduced ratio. So we would press Math, enter, enter, and we would get 5 over 4. Because we want a reduced ratio, a reduced fraction would be the scale factor. Okay, in the last example, I'll have you go ahead and write it out and draw the picture as well. We're going to find the value of each variable. This time they're telling us that the two triangles are similar. So we don't have to determine if they are. They're telling us that they are. So that having been said, I know I want to find x and I want to find y, because those are my two variables. And in order to do that, I've got to set up my ratios. I'm going to do that using the similarity statement. JL will match with QS. LM will match with ST. And then JM will match with QT. And now that I've set up my similarity state or my proportion as letters, I'm going to fill in the letters with their values. So JL, I come over JL, it's 3y minus 2. And QS is 5. Okay, so pause the video and go ahead and finish up these last two ratios, filling in the values for LM, ST, JM, and QT. Okay, and this is what you should get. If you notice that these two ratios have variables in them, but this one doesn't, this is the one we want. That's our scale factor, 4 over 2 or 2 over 1. It doesn't matter what you use. This is the one we're going to use to solve for x and then separately use to solve for y. We use that scale factor to find the missing variables. So what we do is we set up a proportion using 6x minus 3 over 3 set equal to that 4 over 2. And then separately, as a separate problem, we're going to use 3y minus 2 over 5. We're going to set that equal to 4 over 2, our scale factor. And that's going to help us solve for x and y. Alright, now that I've set up the proportions for you, go ahead and pause the video, solve for x and y, see if you get what I get for x, and see if you get what I get for y. Okay, and you should get that x is 1.5 and y is 4. If you did not get either of those values, or you're still a little bit confused, go ahead and raise your hand.